In this video, we are going to see how to describe vectors from the information given and how to perform operations with vectors like addition, subtraction, and scalar multiplication. A vector has magnitude and direction. We represent vectors with an arrow to some specific direction, and we are going to describe the direction with angles. Now, look at this example. A car moving with a speed of 80 km per hour due east. Now, this is a vector quantity as it describes the magnitude and direction. In this example where a worker pushes a cart with a force of 55 newtons, here we only have the magnitude. So this is a scalar quantity where we are missing the direction. In this example, we are going to see how to describe vectors from the information given. Now, in each problem, we are given both the magnitude here and the direction with angles. Now, there are three different types of information regarding angles, so we are going to see how to describe vectors through those information. Let's start with 2a. T equals 20 feet per second at a bearing of 65 degrees. Now, to draw this vector, we first should have our coordinate system. Since it's 65 degrees, we can conclude that it's in the first quadrant, so I can draw the coordinate plane like this. Now this will be my north, and since this is a bearing, I should go clockwise 65 degrees from north. So this means the angle between the vertical axis, meaning north, and my vector should be 65 degrees. Now, I have to define a scale to show the magnitude of my vector. So I'm going to say 1 centimeter to 5 feet per second. So my vector will be 4 centimeters in length. So I'm going to measure this with my ruler. So what I should do is I'm going to draw my coordinate axis. I'm going to define my north as the vertical axis, and then I'm going to measure 65 degrees of angle from north with my protractor, and then after writing my scale, and it completely depends on my choices, I'm going to draw an appropriate length for my vector. In my scale, it is 1 centimeter to 5 feet per second, so it will be 4 centimeters to represent 20 feet per second. You can consider 1 centimeter to 10 feet per second, so in this case, your vector should be 2 centimeters in length. Now, this kind of bearing is called as true bearing, where you start drawing clockwise from north. Now in 2b, we have a different kind of bearing. The question says u equals 15 miles per hour at a bearing of south 25 degrees east. So considering my coordinate plane, the southeast will be the fourth quadrant, so my vector will be around here. Now, to find the direction of my vector, I'm going to measure 25 degrees of angle from the vertical axis. So my vector will point somewhere like this as my angle will be 25 degrees. Right? And if I define my scale to be 1 centimeter to 5 miles per hour, then my vector will be 1 to 3 centimeters in length. So I'm going to draw a vector which is 3 centimeters long. That's how I describe my vector. Now this kind of bearing is called as quadrant bearing, where you just define southeast or southwest or northwest, whatever. You're going to define which quadrant you're going to draw your vector, and then you measure your angle according to, this is very important, the vertical axis. So if this information, this vector is given for northwest, for example, 25 degrees northwest, you would draw your vector like this with a 25-degree angle with the vertical axis. Okay, now let's look at 2C. Now the information given is M equals 60 pounds of force at 80 degrees to the horizontal. Now here we have this horizontal axis, and we are going to measure our angle of 80 degrees compared to the horizontal axis through the anti-clockwise or counterclockwise direction. So I'm going to measure 80 degrees, as in the figure, from the horizontal through anti-clockwise or counterclockwise direction, and draw my vector. Now my scale can be like this: 1 centimeter to 20 pounds of force. So I have to draw 1 to 3 centimeters long vector in this direction. You may have a scale of 1 centimeter to 10 pounds of force, so this means you're going to extend your vector to 6 centimeters. But in my scale it is 1 centimeter to 20 pounds, so it will be like this, 3 centimeters, and the degree will be 80 degrees with the horizontal through anti-clockwise or counterclockwise direction. Okay, now is your turn. Now draw these vectors on your notebook and show me your work.